USB, I was going to stick it in. I don't. We'll do our best.
All right, ready? Ready? Yep. Okay. Well, everybody, thank you for coming. This session is called Access and Preservation for Polynesian Television Collections. And speaking today is Janel from the head archivist at the Moving Image Archive at the University of Hawaii, West Oahu. Miranda from the GBH Archive and the American Archive of Public Broadcasting. She's our digital ingest manager. And Owen, also from the GBH Archives and the American Archive of Public Broadcasting. He's our metadata operations manager. We'll also hear from some of our colleagues at American Samoa. They couldn't make it, so we did the recording. So I will hand it to Miranda. Hello. Oh, cool.
All right, so hi, thanks for coming. So just to give some background on like kind of who's talking and like who we're talking about, I'll start by introducing some of the players, first of which is AAPB. So AAPB, American Archive of Public Broadcasting, is a collaboration between Library of Congress and GBH to coordinate a national effort to preserve and make accessible the significant public radio and television programming for the last 70 years. So as a collaboration, the Library of Congress is responsible for the long-term preservation of the digital files, while GBH spearheads, oh my goodness, sorry, while GBH spearheads access and outreach and metadata. And then together we share overall governance, policy, collection development, ingest and access, and rights decisions. So we're kind of talking about two different projects in this talk. So the first of which is the Melon Project. So the Melon Project was a grant given to us by the Mellon Foundation, surprise, surprise, where we were given $16 million very generously from them beginning in 2023 with the hopes of digitizing 150,000 tapes over the course of 4 years. And the main goal of that was to add kind of more content from underrepresented communities to the APB, which can mean like underrepresented communities, like geographically or like culturally or just, just anything really. So thanks to the Melon Project, we were able to partner with stations and organizations across the US to get the materials digitized and added to the APB. And through this grant, we were able to partner with Ulu and PBS Hawaii. So we'll talk a bit more about that in a little bit. The other project we're kind of that's kind of important in the context of this is I'll just call it the KVZK project. So the KVZK is the station out in American Samoa. And they were granted a Clear Council on Library and Information Resources Digitizing Hidden Collections grant, which began in 2020. That one has since ended, and we're currently on a separate National Endowment of the Humanities grant to kind of continue that same project. But basically, the main goal of that project, or the two projects, I guess, the KVZK project, is to digitize 11,000 plus tapes from American Samoa, which really span like 1964 to 2020. And it really covers everything from like Fatasi boat races, political events, pageants, Flag Day celebrations, just like news. You can see some examples here on the screen. But yeah, you'll hear Neil and Aaron talk about them in more detail later. All right, I'll pass off to Janel.
Aloha, everybody. Good morning. Thanks for being here so early. Uh-oh. My name is Janel Quirante, and I am the head archivist at Ulu Moving Image Archive. And I am so proud and happy to be representing Ulu at our presentation this morning. And I also wanted to say that I'm also super proud to be a supporter and a person who loves public media, especially now. So let's see. So ulu ulu is a Hawaiian word that means collections, assembly, or gathering. And our archive is located on the campus of the University of Hawaii at West Oahu. And I'm really excited to share a little bit more about our work during the professional site visit this afternoon, if anybody is able to join us on that tour. Our mission is to perpetuate and share the rich moving image heritage of Hawaii through the preservation of film and videotape related to the history and culture of Native Hawaiians and the people of Hawaii. I've known about and been super impressed with the American Archive of Public Broadcasting project for several years. And I was very honored when the team reached out to Ulu Ulu and asked us to participate and to collaborate on the digitization of the PBS Hawaii collection, which is held at Ulu Ulu. For this project, we contributed 1,471 videotapes that span the years from 1971 to 2008. And these programs cover a variety of different genres, including talk shows, documentaries, cooking programs, election, and political news coverage. These programs were all produced locally by PBS Hawaii and with such titles as Dialogue, Spectrum, Pauhana Years, and International Kitchen. The shows represent community-focused programming aimed toward local audiences and focused on issues and subjects important to Hawaii's residents. And these shows still resonate and entertain today. One of the more popular series right now at PBS Hawaii is a series called PBS Hawaii Classics, where the station is rebroadcasting a lot of these old programs that were, some of which were digitized through the AAPP project. And I'll talk a little bit later about how Ulu Ulu is continuing to work with the AAPP team on this project.
Okay, so we've sort of set the table now. So I'll sort of talk a little bit about why this metadata that we'll be talking about during the session is like so important, especially in the context that I work in, at least at the APD. So, all right, so for both the melon related Ulu Ulu materials and the KVZK project, the new collections really begin their life when stations send us an inventory of the tapes that they'll be sending to our digitization vendor, which is then transformed into records in our backend system. Very, very sexy stuff up here. So these inventories are often pretty low on cataloging because the goal at this point is really just to get the tapes out the door rather than to have like beautiful cataloging. And also a lot of the time, stations just have information from the tapes labels as indication of what's on the tapes. There's not always like a catalog or like, a lot of information just because like it hasn't been digitized. So it's kind of, sometimes it's anyone's best guess as to like what's on there. So during this phase, catalogers at AEPB just focus on generating records for the tapes. So you can kind of see here, like the initial inventory, this one is from American Samoa, gets turned into this kind of baseline record with, like it's fine. So as you can see, this like original kind of baseline record is just kind of, very basic. It doesn't have like a ton of information to work with. And then AEPB users might have a hard time finding these materials if it just kind of stays at this level of cataloging. So for example, you can see there's not really a description. There's not like credit information of like who's talking or like who's present. There's some dates, that's good. There's a title, that's good. So like we do have some stuff we're working with, but we're also missing some important information. However, once we get these digitized files back, we're then able to look at the actual contents of the tapes and add more information in. So the fun part, once we get the digitized files back, we then work on cataloging them in the hopes of improving the metadata so that they're just like more discoverable. So they kind of become from the version on the left, as one example, to something on the right, which has been viewed and cataloged and kind of, zhuzhed up a bit. So you can see here kind of the difference. There's like a description. There's more information about like the topics. There's, you know, you can actually play it now because it's been digitized. So, you know, just a little bit more information. As I'm sure you all aware, though, this type of thing has a lot of challenges to it. You know, the main challenge that we face at APB is just there's so many materials and there's so little time to like catalog them. So, you know, how do we tackle those? We also have sometimes metadata issues, just because, you know, we're dealing with not a ton of metadata and sometimes it's not super accurate. So, you know, we have to kind of contend with that as an issue. And then speaking specifically to the American Samoa collection, a lot of the materials are in like Samoan, which like is not a language that anyone on our team at GBH speaks. So there's also kind of a language barrier going on in terms of just cataloging like the information that we have from them. So one way that we have kind of been dealing with these is by using VisAids, which basically is just visual aids, right? Yeah. So it's basically the output of a machine learning tool, which Owen will talk about next. But basically, a tool is run on a given piece of footage, which then pulls out any scene with text and pulls it into a package called a VisAid. So here's kind of an example of what the VisAid looks like. It really has the benefits of just pulling out, you know, information that makes cataloging a lot easier and putting them all in one place, so that we don't need to like comb through the video for more information. It's just a lot easier to work with as a cataloger. So as you can see here, here's an example of like kind of before and after of an episode of dialogue. So VisAids have kind of helped us pull out useful information about the record that we can then use to make more findable by users. So for example, you know, the original description, it was there, but it didn't have like a ton of information about who was present or who was talking, which we now have in the example on the right. Let's see, I think that's the main difference in this one. It did have a date originally, which is, you know, good. Then my last example is from KVTK. So this is an example of a record that is entirely in Samoan. Again, not a language that anyone on our team speaks. So we were able to use the VisAids to kind of pull out the actual Samoan text and then put that into the program descriptions so that folks who are like in Samoa wanting to search the catalog in their native language, they can do so. We also do add an English language brief description. It just says like Christmas choral performance. And then we follow that with the text in Samoan that we found in the VisAid. So we're trying to kind of make it more usable for all you know, English speakers and Samoan speakers. So that's, you know, VisAids have been very helpful in that regard as well. So I will pass it off to Owen.
Thanks, Miranda. I'm going to talk a little bit about how we make these VisAid things that Miranda was just telling you about. So, as Miranda was saying, the primary goal for the visual indexes or VisAids is to give the cataloging team user access to key scenes in the video and thereby improve the cataloging process. So what we're looking for are these scenes with text. And the key scenes with text are things like the credit sequences or the Chyrons or the program slate. We'll talk a little bit more about those in a second. But if you can pull all those out, they give you a way to visually navigate through a video. So in order to make a program that could pull out the scenes with text, we wanted to use machine learning and we wanted to use computer vision. So as you may know, computer vision's gotten awfully good. Computers are pretty good at telling you what the content of an image is. But the way machine learning works is that a machine can only classify into the categories that it's been acquainted with. And most of the machine learning for computer vision so far has been focused on categories that are different than the ones that we're interested in. In other words, none of the computer vision tools out there know what a slate is or what the Chiron or lower third is. So we had to create a bunch of training data to improve the tool for ourselves. And so to make a lot of training data, we also made some new software called the keystroke labeler that allows you to very quickly label images. So our first step was to create training data by taking images from videos and manually labeling them. And at this point, between me, some AAPB staff, the team at Brandeis, and a bunch of interns, we've actually hand labeled over 100,000 still images from different videos. This is a little bit about the keystroke labeler, and I won't go into this if you're interested, I can tell you more about it. But I think the more interesting thing is to look at the kinds of categories of stills that we're trying to label. So if you imagine a person sitting in front of a computer and going through a video, maybe getting one frame every 1 or 2 seconds, and then pressing a key that indicates which of these kinds of scenes it is, that gives you an idea of what it's like to create our training data. So if they see this, the one with bars, you type B, or if you see a slate, you type S, or if you see a logo, you type L. If you see the main title card, you type M. If you see a Chiron with a person identified, you type I for person identification. So I'll put this up here for a minute because it's sort of useful to get yourself acquainted with how we've thought through the different categories of scenes with text in broadcast television. As you're looking at these, you can, I think, imagine how having these at your fingertips would make the cataloging process a lot easier. Okay, so with all this training data in hand, that's where we got into our collaboration with the computer science department at Brandeis University. So a couple people who are sitting out here, but this is all part of the CLAMS platform, and CLAMS is Computational Linguistics Application for Multimedia Services. CLAMS is a set of applications that are basically machine learning tools for analyzing audio and video. And within the CLAMS platform, there are particular CLAMS apps. And so we used all the data that we took and combined it with an existing computer vision backbone to create a CLAMS app that does scenes with text detection, SWT detection, what we call it. All right, and then once we have the CLAMS output, which is in a JSON-based format called IMIF, we take that data that tells you where all the scenes of text are, go back to the video, pull out the still images from the scenes of text, and arrange them in this visual index or VisAid, the thing Miranda's been talking about. So as of June 2024, so over a year ago, all new videos coming into the AAPB have a VisAid made for them before the cataloging process. And as of this month, we've created about 20,000 of these things. That's all the new accessions, including about 1,500 for materials in the PBS Hawaii collection, which were actually contributed by Ululu, and more than 3,000 from KVZK. And we're also experimenting using these for other things that might be useful actually for rights review to help us determine what to think of the online reading room. But at this point, they're primarily for cataloging. I wanted to give you an opportunity to actually interact with one of these things. You can either scan the QR code here, or I've got some pretty short bit.ly URLs. I'll put this up for a minute in case you want to type down the bit.ly URL. It will work on your phone. It's designed to be used on a laptop where you're actually doing not a laptop, or actually, ideally a dual monitor setup where you're doing cataloging on one side and have a video on another, but it'll actually work on the phone too. And it'll give you a sense of what kind of information these things have for you. One thing about the VisAids is that it allows you to actually have different kinds of views of the video. So this is 2 images of the same VisAid. On the left, we have only the Chiron scenes collected, only the Chiron scenes selected. So you see just the Chyrons from the video. Over here, we have only the unlabeled samples, the scenes that don't have any text. And so you can see it gives you a very different view of the video. And these VisAids with the unlabeled samples are actually really useful in cases where you've got some B-roll and it doesn't actually have any scenes with text, but you still want to get a visual overview of what's in there. All right, so these things have been really helpful for cataloging. But as Miranda well knows, you still have to look at them and type the information off them. This is what our cataloging team does. This is what we do these days. Wouldn't it be nice if we could pull the information off automatically? In other words, get from a scene with text with a Chiron like this to a nicely broken down set of structured information. If you want to hear more about this, come to the session in this room in the next in the hour after this, and you'll hear more about it. All right, back to you.
Thanks, Owen. So I don't know about you, but when I first saw the visaids, I was like, oh my God, I don't have to watch the video to identify the people. You know, we can create really robust and accurate descriptions for our catalog records without actually having to watch our, our footage or even scrub through footage. And by just accessing these really, really amazing visaids. So when Ulu began this project, I expected it would be like a typical digitization project that we've worked on and completed in the past, which it was, except to a much larger scale. When I was preparing this presentation, I was thinking about, oh, should I tell people about all of the shipping issues that we had to go through from Hawaii to get 1,500 tapes across the country. But I'm like, no, these visaids are too amazing. I'll talk about that instead. But I'm happy if anybody's interested in shipping logistics from Hawaii, I'm happy to talk about that as well. So what I didn't anticipate was this really wonderful sharing of metadata from AAPB that we're now using at Ulu to enhance our own catalog records. So along with the digital preservation files and the mezzanine files that we received back, Miranda and Owen also shared spreadsheets of exported descriptive metadata and the visaids corresponding to the PBS Hawaii programs that were digitized. At Ulu, we've now embarked on a pilot project to map the AAPB metadata to our catalog fields, using the visaids to confirm names, credits, and dates, as well as referring to the AAPB generated transcripts to assist us with enhanced summaries, adding subjects, and creating captioning for our content online. We are fortunate to have a Rosalani intern / AMIA Pathways fellow working with us over the summer, who worked to prepare the records for Ulu's online catalog by formatting the mapped metadata to conform to Ulu standards and by selecting short preview clips to stream online. So here's an example of a PBS Hawaii program as it appears on the AAPB catalog. When I was first preparing this presentation, Hawaii had just gone through a tsunami warning. But now this week, I think I picked the wrong natural disaster to use as an example. I should have picked a hurricanes episode. So this episode of dialogue is called Tsunamis, Waves of Destruction. And what you see here on the screen is how this record appears on the AAPB catalog. And you can see the different metadata, including series name, episode title, and episode description, date, and duration. And here's a portion of the visaid that corresponds to this same episode. The frames capture the lower thirds for the host, Lynn Waters, as well as the names and titles of the guests, Harry Kim, Chip McCreary, and Brian Yanagi. At Ulu, we were able to confirm and note all of this information without needing to watch the full program. And so now here is how that same record appears on Ulu's catalog. The same program with the mapped metadata. The information has been mapped to our catalog fields. We've added a context statement to the summary. The data has been formatted to conform to our cataloging standards, and a short preview clip accompanies the description. But what's also nice with this project with AAPB is that the full-length program is available through their online catalog. And so on Ulu's record, while we're only able to show a short clip through our own server, we can link directly back to the AAPD catalog so that if researchers who find this record on our site want to watch the full program, they can just go directly to AAPD to watch it, as well as to read the transcript. Another new field that we added was a preservation supported by credit. So right now it says American Archive of Public Broadcasting. And as we continue to add records that were generated by this project, they'll all be linked by that same credit. So somebody could simply click on that link and bring up a results list of every program that was part of this project. You're welcome. You're welcome. And so I had to put up a little spreadsheet screenshot, but this is how we've been mapping the data from the AAPB spreadsheet, metadata spreadsheets, as well as the direct links to all of the visits. This is our working spreadsheet where our intern over the summer, as well as staff moving forward, will be working to modify the data, enhance the summaries, and conform it to our standards. So there are 352 episodes of dialogue, and that's only a small portion of the nearly 1,500 shows that were digitized as part of this project. Our intern sadly is no longer working with us, but I don't know if there's any students in the audience. We do have continuing internship opportunities at Ulu if you're interested every semester. And speaking of interns, this is Connie. So she was our Rosalani intern and Near Pathways Fellow this past summer. And she got to meet her brand new hero, Dan Boylan, who was the host of Dialogue, the show that she spent weeks and hours watching, doing quality control, enhancing the metadata. Little did she know that Dan Boylan visits our West Oahu campus all the time, loves the library, and loves saying hello to the archivists. And I think even Owen and Miranda and I were on a Zoom meeting, and Dan came by, and so I brought him into the room so that he could meet these guys as well. But I wanted to end my portion of this presentation with this picture, because to me, it's a really great reminder of why our work to preserve and make accessible public media is so important. It's the passing of knowledge to students, young people, and new professionals, and it's the human connection within the history, stories, and memories contained in our archives.
This next part is a video, so just bear with us for a sec while we get that set up, please. Let's see. That we can have something. While we're getting set up, I'll just went through a little bit. But basically, so yeah, we've been working with Neil and Aaron in American Samoa for the last couple of years now. And you know, we've been great to work with. They couldn't be here, so we did like a recorded video just because it's very important to all of us that you get to hear directly from them about kind of the project and like how it's been for them. So yeah, that is what we're going to be showing a little bit.
Really fascinating the physics of doing the board. Really great. I was curious, do you have like closed action metadata in the like line 21, or do they not? Because the technology of the
I think I can address that. In some cases, yes. Our workflow right now did not have those being delivered to us. They delivered to our conservation partner, the Library of Congress, although we're actually working on.
Not me personally, but my neighbor down the hall.
Yeah, we're working on integrating those in places, especially where we don't have a high quality transcript. But yes, thinking about how the information, spoken information, relates to on-screen information is where we're hoping to go.
Cool. Yeah, I like the V report. I don't know, I believe with like current XFN type iteration, it's very quickly create closed caption transcripts from files as long as it's line someone that every caption file. So, you know, this is just really cool. I see like confidence of that being with the powerful.
Yeah, exactly right. Oh, this is the microphone that's probably, but yes, combining speech data with the visual data is the dream. It's complicated, but we're working on it.
Very cool. Very.
Oh, so I think we can go back to.
Well, can I say
Oh,
just
yeah,
one thing? I don't know if any of the visaids captured it in this presentation, but at least with a lot of the PBS Hawaii programs, there was no closed captioning at the time of broadcast, and so you'll see the sign language interpreter in an inset window. So maybe one day that can be that can be interpreted as to create.
I started to think this kind of was a visual interpreter. Was that done as an accessibility feature of things of the closed caption data?
Yeah, I think at the time of broadcast, yes. Yeah.
It's really awesome.
Name's Aaron Hall. I'm the director of the Office of Public
Sorry. Okay, all right.
Information, which is also known as KVZK TV.
My name is Neil Bernard. Right now, I'm the current director for the NEH Digitization Project and Translation Project.
Initial funding came through in 1964, and it was for Department of Education remote learning programs in the 60s. From that point on, DOE was the main stakeholder of the station until it was switched over to Office of Public Information, where it currently sits now under the director and the government.
What the project intended, it's all the media files that we have from KVCK from the beginning, from 1964 all the way to 2020. We're in the process of digitizing it and also cataloging it and translating it. That way, for future references, people can actually watch it. And I know Samoan language, mainly with a lot of our people that's abroad, they don't grow up learning the Samoan language. So it's a way that they can watch it, understand the language, the difference in English as a training tool.
We have nationwide, actually worldwide reach because of military members, service members. who are based out in Korea, Japan, and so forth. So our reach is not only here locally, but is mainly our community all around the world. We grew up watching KVZK. It is a part of our lifestyle and our culture. So everyone has some tie to TV, to the KVZK TV station, and depends on us not only for the current matters that are happening here in American Samoa, but also for the archival videos that we end up with, that we broadcast on the daily, 24 hours a day. Through this project, we've been able to enhance our relationship, I'd say, with the public, because now it's not just accessible through Channel 2, it's accessible through your phone and through the internet, to be able to log into these digital archival websites like AAPB and go search for the content that you want to watch. So, having it on demand, on hand, has really built a better relationship with, us and our end users. And it's something that we want to carry on through time, because as we say here, today is tomorrow's history. So 10 years from now, what we're filming today is going to be looked upon at that time as history. We'll be showing our kids and hopefully our grandchildren at those times. So, realizing that, this archival project is not just for the past, it's also how we will take ourselves right now into the future and make sure that we archive everything properly, all our tapes, documents, and so forth, because all of this lives past our lifetime. Just recently, we celebrated our 125th anniversary of our, Flag Day to America. To be able to look back and view, especially through this program that we're, currently in, being able to view all the programs that we currently have of all the flag days that we've covered up to a certain amount of time. That's a testament of programs that we've been able to capture, document, and archive. Through time, we've been able to watch years and years of Flag Day celebrations to our alliance with America. We are a cultural, community. So there's high chiefs, matais, just cultural influencers that are not around anymore, that are previewed not only by visual, but also with audio. So you get to hear them talk. So it's real life, just, with being able to witness them in real life really brings the films and the reality of the value of TV and what we do here.
We have our Super Bowl every year. It's our Fautasi racing boat. The two things that they look forward to watching is the Flag Day ceremony and all the Christmas ceremonies. But the main thing that they tune in for is that race. It's a race between all the villages. They have their own canoe. It's like a 50-foot canoe boat. But that's our Super Bowl every year. That's what everybody looks forward to, and it's a huge thing. So, like I said, no matter where you are, if you grew up here, you'll know what KVCK is.
So a lot of the challenges that we have is exactly the environment that we live in. It's tropical. We just came out of probably 2 months of rain. We've already hit our precipitation goal for the year. So it rains a lot here. And it's, very high moisture index and so forth, which is for any analog media storage, that's going to be a nightmare. through the years, so even looking at our infrastructure, power outages and so forth, because our TV station was supplied with a generator and so forth for outages. But there were times in the past where there would be rolling outages, and when the generators weren't working, that would be time for moisture to be introduced into these air conditioned rooms, which would then pass on to the tapes and so forth. So not only the environment, but also our infrastructure to support a stable, environment for our tapes, which were all the challenges on storing them properly into a certain standard. We're not connected by land to the continental US. So now we're talking about ocean, which is then again the same factors of moisture and so forth, and now seawater. And so the challenges that we had was making the decision on how we were going to transport them and not corrode the tapes any further, which means that we air freighted everything off island to the continental US, which brought a larger price tag to the shipping cost that was originally budgeted for this project. We have not released much footage from the archival on our local broadcast because the process that we're trying to do now is separating them, and then scheduling is they have to review the films and make sure that the labels match the event before they push it out to a schedule. We did that because of limited funding, so we don't have to create a whole nother team to come in and work on it. They can do it with their daily workflow. We have pooled, a couple flag days and so forth for Manua, and some of the Fautasi footage and so forth from the files. But on the local broadcast, it's been very minimal. A lot of the feedback is coming from the AAPB website. I promote it whenever I talk to people, especially when I talk to former football colleagues, and they're the ones that people I played high school football with. They're the ones that really want to watch it, and are very interested in showing their children that they played football and so forth, so that they can show their sons. So that's usually how I promote the archival footage, is having that online access.
I believe I did put out 3 videos, one from the 70s, one from the 80s, and one from the 90s. They were all pageant videos. One thing big over here as well is our pageants. We have a Miss America Samoa pageant. I believe we have 3 or 4 different pageants, but it's huge here. It's another thing that carries KBCK's name. They're always documenting that. But I know I put out, I believe it was a 1978 or the 79 pageant. It was one of the first pageants. The 86 pageant, and there were pageants that I found throughout the videos on the Sony CI film. But I got a huge response. I mean, people were messaging me, and it's actually helping me learning my own heritage, that something I kind of forsaken for far too long. But it's a project that I want to make sure that we get through, and just a platform where it doesn't matter where you are, so you don't have to be Samoan. If you want to learn about Samoa, anything about Samoa, this would be that platform.
The future for the archival digitized archives is just accessibility. It's having access to your culture, the culture, our culture, you know, just like what Neil was saying was, there are Samoans off island that have no touch through an arm's length. They can't even touch their culture. Now it's not even an arm's length away. It's in your hands.
The heritage part where, this is what we're doing. We want to be able to have a platform. So not only that a Samoan or even the Samoans that you do know, a lot of them don't know our heritage, and it's something that they can fall back on. And for those also that do know our heritage and they want to learn more, they want to watch all these old films and study our actual history. There's a lot of American Samoan history that a lot of people don't know.
We have to remember where we come from, and that's what this is about, is that we know where we came from so we don't lose ourselves in the mix. And the archival project is exactly to put in concrete our foundation as a culture and a society to make sure that our people don't lose their way through time. So thank you.
I do want to give a big shout out to Nick Ranieri for editing that video, because that was originally like a 45-minute Zoom call, so condensed into 13 minutes. So big thanks to him. Thanks also to Robbie for doing all this. And that's pretty much we have one more slide saying the thank you, but if anyone has questions, feel free to shout them out.
Sounds like the next session might be covering this, but I wonder about error rates with generated by the machine learning.
Yeah, thanks. You're right to worry about it. This is, it's making predictions about unseen instances based on the data we've given it, and it gets things wrong. So we do sometimes misclassify scenes, sometimes things that are Chyrons will be classified as other text. Distinguishing between a logo and the main title for a show is incredibly hard to do with just visual information. So what we do for those is we try to err on the side of having more false positives and show things that might be relevant scenes with text, even if we're not sure. So we increase the sensitivity and turn down the precision a little bit. Now, as far as the taking the information off the still and getting the text out of it, that is the topic for the next session. And we're just embarking on that project, but we'll stick around for the next half hour and tell you more about it. And thanks, Matt.
Yeah.
Sometimes we identify the Medicare ID as entities. This is not done by law or something. This is always.
Yeah, so I can answer that in two parts, and it's related to the last question. For correctly identifying the scenes, what we do is we try to give to the human more scenes than we think actually have data in them. So we see the cases where it thought there was relevant information, but there wasn't. with the idea that a human can quickly go, oh, well, that's not relevant to me. So that's one way to keep a human in the loop. As far as what we're going to be talking about in the next session about pulling the information off the scenes of text, we'll always have a system where a human can both see the original still from the video and the extracted text before that goes into the catalog. So there'll be a moment of seeing what's extracted, verifying it, doing any corrections, and submitting it. It'll still be a human-based cataloging workflow. We're just hoping to take out of that some of the things that are the least fun things for humans to do, which are, manually typing every single character. So it's still a very much human-created metadata. Does that answer your question? Yeah, thank you.
I'll also hop in and say, we also have cataloging is just one round of the viewing or the checking that we do of these materials that we get back. So we also do like a QC round, just to kind of do check the quality of what we're getting. So where we'll kind of, play a little bit of it and just make sure okay, it's playing well. There's not anything strange going on in here. The capture was good. And then we also do a rights review, kind of at the same time sometimes, but we also check the rights. So at that point, we also do kind of compare the scenes with text against what is in the actual file. And if they don't match, then, we definitely, I don't think it's happened yet, but if it ever happens, then I definitely would go back to Owen and say hey, what's going on?
And then I also wanted to say there was a third round of checking. So once the files and all of the visits and metadata come back to either or to any of the participating partners with the project, we do have a chance to take a look at the footage, be kind of the subject experts of what we expect to see. Compare all of the information that was generated from the visaids and other metadata extraction and correct it as needed. And so that's what we're doing right now at Ilu is fine tuning the information to make sure that it's accurate and correct. And I also wanted to say, I do also appreciate that there are more within the visaids. It's really helpful that there are way more frame grabs than are necessary, including frames that have text or a graphic that might look like text but isn't really text. And so it is still really a much more quick process for the human eyeballs at Ilu to see, an array of frames and very quickly figure out, okay, that one's actually text, that one's not relevant, that's a graphic, or that's bars, and to make those human decisions about what to include in the catalog, rather than having to watch the full program and take time doing it that way.
I think.
So this.
Happy Thanksgiving. No? Okay.
Okay, you don't have to. I guess I'm starting actually.
All right, I guess we will get started. This session is understanding on-screen text. The AI tool struggle with Hawaiian Chyrons. And this is a little bit of a follow-on from the one previously. But speaking today, this morning, is Kelley Lynch, computer science PhD candidate at Miranda University. Chen, computer science PhD candidate at Miranda University, and Owen from the TBH Archives and the American Archives of Public Broadcasting, metadata operations. And I will hand it over to whoever's going first.
Yeah, I'll start. Thank you, Karen. Like Karen said, this is a collaboration between several people. Kelley and I are going to be presenting today, but also very much involved in this project has been Yangyang Chen, who's sitting right here and who's been has informed us about questions about the languages involved in the collections we've been analyzing. And also our former intern, Gabrielle Keene, who was not able to make the trip out here, but who did a ton of work curating the data set that we ended up using for this project, and also annotating by hand so many of the images in the data set. So this wouldn't have been possible without her work. So I wanted to make sure that she got acknowledged here too. Okay, so like Karen said, this is a continuation of some of the topics that were discussed in the last hour, but if you're new to this, I wanted to say that the context of our project is the American Archive of Public Broadcasting. And the American Archive of Public Broadcasting is a collaboration between the Library of Congress and GBH, where I worked, coordinated a national effort to preserve and make accessible historically significant radio and television programming for the last 7+ decades. So, in the APB, we get many, many hours of old broadcast television, and that's fantastic. It's amazing that we get to preserve all of these. But a lot of the video we get comes with really minimal metadata. If you were here last hour, you got to see a lot of our processes for creating metadata, but the long and the short of it is that one way that we can accelerate the process of creating metadata beyond just watching the videos is to find in the videos these key scenes with text. These scenes with on-screen text tell you a lot of the bits of information that you would like to have in your catalog records. So on the left, you see a program slate. This is not something you would actually have seen on TV, but the people in the radio station or the television station would have seen as they were preparing to put it on the air. Also, you see information in the Chiron or lower third that often tells you who's speaking on camera. And of course, we all know credit sequences at the end of films and television. So our question is, can we use this information to create rich catalog records, and can we do it expeditiously with the help of AI? Okay, so the computing context for our project is the CLAMS project, computational linguistics applications for multimedia services. And the we here is primarily the Brandeis team. So this is written by our colleague, Rim, who was also heavily involved in this project. He said, we developed for libraries and archivists the CLAMS project to help enrich item-level descriptive metadata by providing automatically extracted information from time-based multimedia collections, utilizing computational analysis tools for text, audio, and video. And the idea is that with a large collection of AV and CLAMS applications, you end up with something you might think of as a smart archive. All right, so our current way of using CLAMS tools is what we were discussing a lot in the last hour, the creation of these visual indexes or VisAids. And if you actually want to take a look at one of these, there's a small bit.ly URL there that you can type into your computer, or you can use the QR code. It will work on your phone, but not as well, but will work on a larger screen. But what these visual indexes do is give a cataloger a visual overview of a long video and allow the cataloger to see at cataloging time a lot of the scenes that are most relevant for cataloging purposes. So here you can see in this VisAid that's on the screen here, the only box that's checked is the Chiron box. So it's showing you all the Chyrons that appeared in the video and allows you to quickly get at all the people who were there. Okay, so far so good. This has been accelerating our cataloging process, making it more thorough and accurate. But a human still has to type the information that they see on the image into the catalog. And that is time consuming and also not super fun. Could we extract the Chiron data automatically? In other words, get from a still image like this to the structured data you see over here. That's the goal for the project that we're talking about now. So if we are successful in being able to do this, it unlocks a new way of doing research in the kind of archive we have in the AAPB. It allows us to construct timelines for frequently featured persons, whether these be politicians or celebrities or community leaders, or even the people who are public media personalities. And so here you have the former governor, and you can see a little slice of his political career over time. And the ambition is to be able to do this at a lot longer scale over many more years, and potentially even across collections when you have national figures who've appeared on multiple public television programs. Okay, so here is the plan for the project that we're working on. So, well, actually, this is the most of what we've already done. We created an evaluation data set. This is where our old intern, Gabby, was so helpful and did so much work for us. We created about 4,000 stills with Chyrons. We manually transcribed each of them. We manually annotated each of them. And then we've also designed pipelines, and Kelley's going to talk a lot more about the pipelines, different pipelines we might be able to use for extracting information from them. We also, because of our integration within the CLAMS platform, have a ready-made system for evaluating these. So this is which I've got to give all the credit in the world to our Ken's not with us today. He has put so much work into making the CLAMS platform not just a platform for creating these applications, but also a platform where the quality of the output of CLAMS apps can be evaluated. And then with that evaluation framework in place, we can run experiments. And so a couple different areas where we're experimenting is experimenting with different kinds of pipelines, which Kelley will talk a little bit about, and also experimenting with how those pipelines work with different kinds of content, whether those differences have to do with different eras in which the content was created or different regions from which the content was originally produced. And in particular, the question for us today is, are Chyrons from Hawaiian TV more difficult than Chyrons from mainland TV? So why ask this? Are there special reasons to worry about Hawaiian Chyrons? Well, so Hawaiian text and visuals are underrepresented in the sort of mainstream computer vision training corpora. And you have different distributions, different ethnic or different distributions of names. The ethnicities of the people who appear on Hawaiian television are different than the ethnicities that appear in mainland television. The text has distinctive typographical features, okinas and kahakos. And there's also a lot of visual complexity. So you see lots of flowers and Hawaiian shirts. And that visual complexity makes it much harder to actually grab the text off of the still images. So the three Chiron images you see here, you see some of the frames that might make you think that Hawaiian Chyrons will be more difficult than some Chyrons from other public broadcasting stations. All right, let me hit it up the top. Yeah.
Okay, so I'm going to start by talking a little bit about the task of OCR. It stands for optical character recognition. So this task is taking an image and extracting the text, generating characters. Traditional OCR models, you may have heard of Tesseract, DocTR. These are traditionally trained or typically trained on documents, like scans, envelopes, like things that are usually white paper with black text, maybe newspapers, but not TV frames. So if, you know, looking back at the previous slide and those examples, there's lots of color, there's complex backgrounds. So those features create a lot of difficulty for these traditional OCR models that were trained on a very different type of data. Alternatively, large multimodal models are general purpose. So these, you can kind of think of ChatGPT, you know, models that are designed to do various tasks, not just OCR. Here, we're going to use two different open weight large multimodal models, LAVA and small VLM2. So we chose these because the weights are open, so we can download them and have that for reproducibility, but also because we don't want to rely on a service like an API, like an OpenAI or Google Cloud, because well, one, these services aren't necessarily reproducible. So if you use them at different times of day, you might get different results because they might be serving a different model to you. So we wanted to choose models that are possible to run on consumer grade GPUs, and also so we wouldn't have to worry about potential rights issues with sending data to these large model providers. Now I'm going to talk a little about the evaluation data set. So as Owen mentioned, there was a lot of work went into the curation of this data set to try to, so here we have a Hawaii set and the comp set. So the comp set is from channels in the lower 48 states. The Hawaii set is from PBS Hawaii. So we tried to get a comparable distribution across time and style. So that was Gabrielle King's work, kind of trying to make sure that the two sets were it was reasonable to compare them and there weren't features that would make that comparison unfair for one side or the other. So here's just some statistics. We have about 1,800 Hawaiian Chyrons and 2,100 from the lower 48. Oh, and so here we divided into name and attribute. So some of the Chyrons just have a person's name, and then others have a name, possibly a job title or affiliation. So that's what that's referring to. And we have two tasks that we are comparing. So first task is transcription. So for this task, we're looking at just passing the image to a traditional OCR model. We do like crop the image to just pass the lower part of the screen to kind of help a little. For the large vision language models, we're just passing the entire image and a prompt, which I'll show in a future slide, that is instructing the model to transcribe just that text in particular. Here's some more details about the particular pipelines we're using for transcription. We tried two different prompts with each of the two models. So that's the 4 different configurations that are listed here for vision language models. The first prompt we tried was the exact instruction that was given to the annotator who was transcribing the text. And then the second prompt was a revised version that is more in the style of prompts that are used with these models. And so we use both of those with both LAVA and small VLM2. Say a little about the numbers here in parentheses. So the LAVA model is available in a few different sizes. Here we're using the smallest available LAVA model, which is a 7 billion parameter model, and also small VLM2 is available in different sizes, and we're using the largest, which is 2.2 billion parameter model. So it's smaller than the lava model, which allows it to run faster and with less GPU usage. For evaluation, we're using character error rate. So that measures the number of edits, insertions, deletions needed to transform the prediction into the ground truth. Yeah, so this is useful for things where like small differences matter, where if we're using word error rate, we might not be able to tell exactly what those differences are. Okay, here's the prompt that we use for the transcription task. Don't need to read through the whole, this is the revised prompt. So the two main points that we're trying to communicate to the model are to focus only on the Chiron and to transcribe it verbatim. So don't leave out any characters, preserve the spacing. Yeah, so these are those instructions. And we also, in the fourth point here, tell the model specifically what character we would like it to use for the Okina, which was also part of the annotator instruction. So we're trying to get consistency between the annotator and the model. Now for task 2, we're moving beyond transcription and trying to get the actual structure of the Chiron. So this is like the example that Owen showed where we had the name normalized, and attributes. So having that structure is very useful to be able to take this output and put it into authority files. Just having a normalized name is useful to be able to track someone over time. And so for key information extraction, we evaluate each field using character error rate. Okay, for this task, we're comparing just these 4 pipelines. So as you'll see in our results slide, Tesseract did not perform particularly well in transcription, and Lava performed better than small VLM2 on transcription. So we chose to focus just on doctr and Lava for task 2. And here so for the traditional OCR step, we use the doctr transcription output, and then we use a heuristic to take that and transform it into the normalized and attribute broken up format. So that's just like splitting the output on new lines and doing some kind of rule-based construction of the normalized name. For the vision language models, we use a separate prompt. So this is the prompt that was provided to the annotator and a revised prompt. And then we also tested a pipeline that used the output from the transcription step and passed that to a llama model, so another large language model, just passing that output text and no image, and prompted the llama model to transform that output into the structured form we're looking for. So this is just an example of the prompt that was used for key information extraction. So this is only a portion of the prompt. We also had a little preamble that's similar to the prompt that was used for the previous task. But one important thing to note here is that we provide examples to the model to try to guide it in having a consistent format. So here, the lower half of the screen in this bolded section, we have an example of what type of text we might see and then how we want the structured name or as written name, normalized name, and attributes listed. Okay, results. So for task 1, here we're looking at CER uncased. So one really common error, especially with the vision language models, is that kind of takes its own, makes its own decisions on casing. And Chyrons often are in all uppercase, or the name is in uppercase and then the attributes are in normal, like lowercase. And if the model is making its own choices or using like normal casing, then the character error rate will be very bad, even if like the semantics of the text is reasonable. So here we're looking at the uncased character error rate. And the best performing pipeline was Lava with the revised instructions. And interestingly, and a little surprisingly, the Hawaii set had, so for character error rate, the lower score is better. So the Hawaii set had a lower character error rate than the comp set, which was surprising. So for task 2, I'll just give you a second to process this table. So we're looking at the Hawaii set divided down into each of the categories and then the comp set. So the interesting thing here, so the best performing pipeline was by far the pipeline that consisted of the Lava output followed by the Llama structure. So the models didn't perform very well when asked to both transcribe and generate a particular structure. The best performance was when we only tasked the vision model with generating a transcription and then asked Llama to revise that. Here, the comp set had a lower character error rate than the Hawaii set for names. So that, and they're quite close. You know, we have about 8 to 9% versus 7%. So that might be a sign that the names are a particularly challenging part of the Hawaii set, which is what we were expecting based on the differences in ethnic background from these names. Now we're going to look at some examples. So here, the common error that we saw was from formatting and punctuation errors in transcription. So in this table, you're seeing the output of a pipeline and then the uncased or unnormalized. So case sensitive character error rate followed by the normalized, made everything lowercase before doing character error rate. So here his name is in capital in the actual Chiron, but the output did its own thing with the capitalization. So yeah, and then the other problem we see here is with the punctuation and formatting. So if those commas had been new lines instead, then the uncased character error rate would have been 0, but the model generated commas here. Another problem we see is extraneous text. So here, and this was a very challenging Chiron, I thought. Like if I was having to type out these characters, it would be, you have to have some attention to detail to get all these spellings. But the model, in addition to correctly transcribing the content of the Chiron, has this additional output. Please note that this transcription is based on the visual content of the Chiron graphic and the image provided. So because of that additional text, the character error rate is over 50%. When the actual transcription part, if we had some more sophisticated post-processing, this also would have been a perfect transcription. This example was just a failure of the model to follow the instruction to ignore any text on the screen that is not part of the Chiron. So we have the file in the corner that was included. in this example, this is a known issue with using large multimodal models for OCR. They rely on the semantic content of the text. So things like acronyms are particularly challenging. So in both of these examples, the acronyms are incorrectly transcribed. And that I think is of particular value in this with this kind of data, because we often see acronyms in Chyrons and very often in news data. In this example, so this is it. We look at first we have the output from Lava, Condoleezza Rice, New Line, Secretary of State, and then in this JSON block, this is the output from doing the Lava plus Llama pipeline. And here, the name is written is verbatim from the transcription output. But in the name normalized, the spelling error in the transcription has been corrected. So that was a surprising finding, because the Llama model doesn't have any access to the image itself. It made this correction based on its own exposure, world knowledge. So that was an interesting finding. So in conclusion, for this task, the vision language models outperform traditional OCR models, and the Hawaiian Chyrons are not necessarily more challenging, but there may be things about the names in particular that do introduce potential problems. And careful post-processing is necessary to make use of the VLM outputs. And post-processing using an LLM could allow for different error correction. And in the future, we plan to use these outputs and allow an annotator to correct them and see how that speeds up the process of creating Chiron transcriptions.
And if all that goes well, we'll hopefully be able to actually do the thing that I was talking about in the beginning, where we trace contributors over time. And so where you have a case of a contributor that many of the locals in the audience may recognize, so you can see the potential for this kind of project to show you how someone's career and life went over time. And on our last slide, we have some links to other parts of this project.
Thank you.
The VLCR, I'm curious whether many people participating about quality of the image or something, and that has an effect on
So to select the particular, we are just using one frame from the identified time frame. So using the scenes with text machine learning model that Owen mentioned in the previous session, we generate scores for each of the frames in the time frame that's been identified as a Chiron. And for this, we take the highest scoring frame from that time frame. So we chose that thinking that that would be hopefully like the cleanest, maybe least blurry. But I think it's kind of, that would be some good future work, I think, is to compare different frames and maybe do like multiple frames for a time frame, use that for some error correction. So there's a lot that we could do there to improve the process of choosing a frame. But for right now, we're just choosing the highest scoring one from the other model's output.
So it's not about creating more than a person, but I was thinking the Lava project and it was something updated in January of 2024. So I'm thinking like, well, obviously you have to go fix that is working right now, but with all the things that we can AI, especially models, all the top models and the new brand models, something like that. I mean, how do you make it so you are balancing like it's working for you, but you always want to be on edge because it's gonna be something that's gonna be help you, it's gonna work better now. And maybe, or I suppose you can do DORAs and try to make it fun, will take some value or something like try to adjust for the changes, but it's always gonna be like a race against like what's going on in the kindergarten right now, right?
Yes, absolutely. Yeah, there are always new models, and I'm sure that a model has come out since these that would probably do OCR better. Would it perform better on these? I don't know, but I think that's why it's important that we've created a data set that, you know, we can now take two models and run them both and get an idea of how they perform. But yeah, it is always kind of keeping up with the newest models, and within the CLAMS project, part of the goal is for our kind of infrastructure to allow us to easily just wrap a new model and kind of have a drop-in app that we can then run evaluation with and streamline all that process.
Remember sitting with him and say, oh, he was really know now, I just foresee that some of the work that you're doing could be helpful for those of us who are thinking that innovation.
Well, we'd love to. I mean, so as the stage we are right now is developing these pipelines and seeing if they are accurate enough to actually put into use for cataloging. And as I was saying at the end of the last session, this will be very much a human in the loop or even a human-centered cataloging process still, because even once you pull out all the scenes with all the names, we still want to have a human check the spelling. But once we do that, then you have a record of, you know, each of the videos from the PBS Hawaii collection where, say, Dan has appeared, and that enables us to make the timeline. Once we get to that point with a given collection, yes, we would absolutely love to hand that back to the local community that produced it and said, here are some ways to look at the people from your community as they appeared over the decades. But it's probably at least a year off before we'll be able to deliver something like that. But thank you for asking. We would love to be able to give that to you. Right, and so that's the other thing is how we integrate the information coming off the Chyrons into an authority database. I mean, in most of the people in public television don't actually appear in standard authority files, so we're gonna have to spin some of that up ourselves too. So that's why this is a long-term project, but hopefully it'll give us ways of indexing the people that commonly appeared on public television across the country. Well, across the history of public television in America. That's the hope. That's a very large ambition.
I think you're talking mostly about text extraction here, but are there tools being developed in TV at all for recognizing the relationship between, say, B-roll and production or distributed or air like off-air broadcast, so that you might determine what the best copy was, and maybe be able to spread the metadata from related films?
So absolutely lovely idea. There's nothing like that underway. I mean, do you have ideas about how to approach something like that?
None at all.
I mean, I was thinking that, you know, you probably could do some image similar, like, vector similarity of two images to associate B-roll with the production version and be able to do the transfer that way. I mean, I can imagine a strategy for doing that. It's just like, you know, we're working with a very small team on this and it hasn't been a priority at this point, but it does seem like it might be feasible. It's a great idea.
Or it's a pretty fancy.
The PC's Hawaii context that you seem to do does have B-roll that is associated with images for them, so if you want to tap those things. Good to know.
Yeah.
Pick up some swag. Thank you very much. Thank you so much for coming and thank you.
And move the back on the cheese.
Oh, make it non, or is it not editable?
Or resend it. Oh, that's, oh, okay. Oh, no worries. No, I'm worried about something, worried about the mission.